Nobody asked for another podcast, so here you go. This is yet another Infra podcast.
Hi, everyone, and welcome to our 12th episode of yet another Infra podcast. I'm your host, Vitaly Gordon, co-founder and CEO of Ferris AI. We're joined today by Ian Livingstone, engineering lead at Sneak, and Alex Clemmer, CEO at Moment.dev. We'll be discussing today the letter calling to pause giant AI experiments and the engineering productivity gains that we'll see with AI. Hope you enjoy. Hi, everyone, and thank you for joining us, folks. Several weeks ago, notable people like Yoshua Bengio, Stu Russell, and Elon Musk signed a letter calling to pause giant AI experiments. Can you tell us a bit more about the letter and kind of what are your thoughts about it?
Yeah, I think the synopsis of the letter is that we should halt AI development for a period of time. And because the pace of AI development is quickly going to outpace the human's ability to control it. And that's bad for humanity. And I think my personal take on this is that a lot of the signers there have like internal incentive to stop certain firms from progressing in AI. So I point out that, for example, Elon Musk has a competing AI lab at Tesla, right? Some of these signers make their career talking about AI safety. So there's an incentive for them to create publicity. There's an incentive for them to go out there and say, AI doom is here. The world is going to end if we don't stop this. I actually think, largely speaking, when you look back and understand what these models are doing, they're relatively stupid, right? Like they're highly relational, but they're just generating the next token, and the training data set's old. And so when I look at this and I think about this letter, I say it's a giant nothing burger in an attempt to catch with a catchy headline that got tons of publicity because it's so outrageous in terms of what they're asserting to be true, that the AIs are about to take over the world. They're going to eat our lunch. Skynet's here. And that's my perspective on the letter itself.
So, Alex, a lot of this letter maybe stems from people not really understanding how kind of LLMs work. And it's primarily this machine that predicts the next word. Like, how possible it is for a simple construct like that to really take over the world?
Yeah, so I think that people who are worried about it, like various types of AI safety issues, tend to fall into a couple of different camps. So one camp of people is like people who are worried that people will use AI technology mostly to do stuff that displaces other people or disrupts other people's lives, or use it for like nefarious purposes, creating like Uyghur concentration camps in China or something like that. There's a second class of people who think that AI is essentially going to become like an omniscient God mode thing, which goes out and creates bacteria, like kills everybody by emailing instructions to like a lab that has it prefab something, and then creates the supply chain that creates bacteria that kills everybody. That's like a real thing that people really believe. My sense is that like Ian, most of the people who signed the AI letter fall more into the latter camp or are super conflicted. And when I think about the possibilities of the model, I think one of the reasons why people are afraid of the model is because they don't really have a clear understanding of how this actually works. The model's job is just to predict what the next token is, essentially. And if you haven't read it, Stephen Wolfram has like a really great book. You can read like the first 10 pages and the last 10 pages and skip the middle 60 pages. And it tells you more or less how this works, which is it's like a giant feed forward network. You put in some input and then it predicts the text. And there's a bunch of stuff like attention heads inside there that make it very good at predicting text that looks uncannily like what a human would write. My assessment is that under the current state where you have 32 tokens of memory, essentially, the capabilities of these models are fairly limited. So all they do is predict the next token. They don't have a way of incorporating new information into the model like directly, unlike humans. So human brains have this really remarkable property that other people can change the state of your brain without your consent at all. Like I can say something to you, and you'll remember that. That's a property that the large language models have at all. All they do is they have this pre-trained network, and the network can predict the next token. It has, I think, a lot of surprising implications. This is one of the reasons why Wolfram is so interested in it, is because it had this like belief for a very long time that simple systems like automata can look simple and you can have simple rules that describe them, but the initial conditions, you can generate these incredibly intricate patterns that are not necessarily explained by the rules or much more complicated than the rules might suggest. And that's why he's interested in LLMs. And that's what LLMs do here, is they're not really simple, but like you've learned this like network of stuff. And what it does, it generates these really intricate patterns that are meaningful to people. But the limitation of that model, like to me, is just, it's like insurmountable. You can't, with 32 tokens of memory, take over the world. Like there's just no plausible way that this is going to happen. I think the argument from the, I guess I'll call them AI doomers, is that this progress will continue until it gets really bad and we have insurmountable progress. Or sorry, did I say 32? I meant 32,000 tokens. So I don't think it's plausible that under the current circumstances, LLMs are going to take over the world. I think that the plugin system that GPT exposes, stuff like that, has the potential for having very serious, like very significant downstream consequences. But I think most of those are governed by people, not by the absolute limits of the intelligence of the LLMs themselves. Yeah, so I don't know. I'm skeptical right now. It doesn't seem to be the case that we're going to be able to significantly increase that memory limit. It just seems like it's going to be complicated unless we have a complete re-architecture of the LLMs, that we're going to have a breakout case where these escape and kill everybody. That's just not, it's not a thing that's on my radar right now, personally.
I think this is a good perspective. One of the things I've been thinking a lot about when I think about the LLMs is their ability to create hallucinations. So I think the LLMs we have today, if you look at ChatGPT, they are some of the greatest conspiracy theorists we've ever created in terms of their ability to invent facts based on information that are that they've trained into the model is pretty incredible, right? It doesn't have any capacity. The LLM has no capacity to know whether what it's saying is true or false. There's no system of truth it interacts with. It's just generating information based on a statistical probability relationship that's encoded into the model during training. And the attention architecture is pretty incredible in terms of what it enables us to do for translating like things together. So from one language to another, or from language into text. Like, it's undeniable that the last 2 years of AI development, and really the last 5 years since All You Need Is Attention paper came out, have been transformative in terms of what this means for humanity. But at the same time, I think we need to take a step back for a second, away from the headlines, and really think, what are these things actually capable of? And Alex talked a lot about it, but also who's on the hook for it today? And one of the things when I read the letter that I thought a lot about was, well, the truth is, like, liability law still applies to all of this. These things create figments of their own imaginations in ways that humans do as well. They're incredibly creative, which is why the place where they show the most risk, or place where they'll impact humans most, is our places of creativity. There was a recent Reddit post someone posted where a graphic designer was talking about how much generative AI has changed their job and removed their joy, because they're no longer actually doing the creation. They're relying on the generative AI to do the creation. And so I do see in places where these generative AI models have a huge ability to impact the future of humanity, and will have an ability to impact jobs and careers, both for good and for bad. But at the same time, I think we have to sit back and also really analyze what they're actually truly capable of. And what they're capable of is creating up lies. They don't know what's true, and there's no system for it to test whether it is true. The future of these systems, liability law covers it entirely. And it's the reason that Google is currently so stuck while OpenAI has so much ability to execute, is that Google has a massive business on the line where OpenAI doesn't have one at all. And so if Bard lies to you, that's a big deal. But if OpenAI ChatGPT lies to you, it's not such a big deal today.
So talking about liability, there was an interesting case, I think just a couple of days ago, where ChatGPT falsely accused the mayor of bribery when he was actually the whistleblower. And now that mayor is suing OpenAI for defamation. So I think it happened in Australia somewhere. But I'm curious if you folks have thoughts on whether that is the world we will going to live in, and actually people can sue the makers of these large language model for basically making false claims.
A lot of the stuff that's happening in AI reminds me of the initial .com boom. And there's this line from the first line of Kara Swisher's AOL.com is, "The truth is no one knows." And I feel that way about everything, about all of this AI stuff. Especially in America, where like case law is settled mostly by precedent. We're just going to have to see what people decide. I think the place where this is going to get really tricky is a place where there's like physical liability. So stuff like cars, like self-driving cars, I think is very complicated. It's very hard to imagine how to engineer a system where it has to choose between like a significant moral dilemma, like ethical dilemma. If there's like a choice between two people on a street, like which one do you hit? Right? Like those sorts of things are things that are like very hard to make automated decisions. For LLMs, I think like LLMs and most consumer technology, most of the danger comes from consumption risk. And consumption risk is basically where a bunch of people consuming or using a platform use it to do things that the platform was not necessarily intended to do originally, but which are nevertheless deleterious. Nobody, I think, who made Messenger thought that it would play a significant part in the Rohingya genocide, but it did. And that simple risk of consuming the thing causes this enormous amount of leverage that makes it a significant attack vector for a lot of different just institutions and bad people and stuff. And my guess is that we don't actually know what the consumption risk for LLMs is yet. So it might be something like search. It might be the case that we're just flooded with fake news. It might be the case that spam bots are way easier to build now. I think we don't actually know yet. Legislation in America, at least, is most of the people who make the rules do not actually understand the rules themselves, or do not understand the technology that they're legislating. My guess is that we will be very slow to catch up on this, whatever the consumption risk ends up being.
Okay. I wasn't sure if you wanted to commit. I think one of the things on liability that's super interesting for us to also just discuss and think about is in the context of what's going on with Section 230. And for those who don't know, the abbreviated notes in Section 230, basically, this is a section in American law that's the people that run the network. So for example, the ISP, the person that has a physical wire running from your house to the telephone pole, to the data center, to the interconnect, are not liable for how you use that. And I think it's also interesting to think about, is it the prompter who's liable, or is it the owner of the model who's liable? And if you prompt a model to ask a question and the model generates something nefarious and you use that, is that on you, the prompter, or is it on the model creator and how it's being prompted? And I think that's in akin to the way that we think about Section 230, that's something that's super interesting and we have yet to see developed. I think based on what we've noticed in the last, let's say 5 years, specifically around what's going on with social networks and the direction of American thought on the reliability or responsibility of social networks, I think what we'll end up seeing is, my bet would be, I think the LLM creators are ultimately going to be the ones that end up being liable, as they're the ones that control, you gave me this input, but that doesn't mean I have to generate an output. And they're the ones in control, and they're the ones that train the model, and ultimately will probably be the ones that are liable. I would be shocked if a Section 230 type extension was made for a large language model, given the current political climate, but that doesn't mean it won't happen. I think there are circumstances where it can make sense, especially if you're providing a foundation model and then someone's doing explicit, like you're using a Lang chain where you're chaining, ensembling a bunch of different models together, then, at what point where does the responsibility reside? Can you identify the specific model who generated the poor result, or is the person that's generating the different chains together? So I think it's a super interesting question. I do ultimately believe that the liability law will help us define what this means and will help us add guardrails, right? Because risk to a business is very real. Businesses spend billions and billions of dollars a year on security, spend billions and billions of dollars a year on privacy. And I think they'll end up spending billions and billions of dollars a year on safety as they deploy these automated systems. In the same way that car manufacturers spend billions of dollars a year in safety, it's because the liability and the downstream implications are too costly. And this is why I also think the AI letter, if we go back to it, think about it, if you think of the context of, and just think of this as just yet another technology of the tens of thousands of technologies that have shaped modern society, this is just a new thing we don't yet fully understand, but ultimately, just like every other new thing, we figure out where the line is of who's responsible for what, and then the risk equation dictates what the business appetite is. And I think that's why we haven't seen big businesses take hold of this yet. It's early. A lot of people don't know how to apply it, but also the risk there is quite large, especially if you think in terms of finance, places like where there's real money on the line.
It's actually very interesting how we keep going back to basically fundamental laws with every new technology. It's kind of similar to how crypto had this whole decentralized properties, and people were talking about, oh, you can put your house title on the blockchain. But at the end of the day, it all relies on the ability of some centralized organization to show up in your place of residence with guns and demand that you do something. And so, Alex, you agree with Ian, LLMs will not be any different. And at the end of the day, we'll just go back to rely on good old-fashioned law in order to make this world normal.
I feel like we're still sorting out the last time this happened, which was the internet, right? Like, we never really did sort out some of the core philosophical conundrums around like content distribution, who owns what, who has the right to copy what. And we've settled in this middle phase where everybody acts like this is a transitory phase where like you have, like news is in terrible shape and stuff like that. But maybe it's not, right? Like maybe this is just the way that it is from now on. And my sense is like, never personally subscribed to the crypto as like the next version of the internet or whatever thing. I think AI might be, like, it's pretty early, but assuming the consumption keeps up at the rate that it is going now, my guess is that it will change the way that we do a lot of things. And the implications of that are like unknowable. And if you went and talked to people in the early internet, they would have had a bunch of ideas, and some of them would have been good and some of them would have been bad. And it would have been hard to know ahead of time what was happening. I think in America, at least, it's going to be hard to legislate this stuff. Like, we haven't ever really been able to legislate things like social networks. We've never really been able to like legislate things like content and moderation and stuff like that. We've had to depend on these like giant, essentially fake nation states to do this for us, like Facebook and Google. And I think my guess is that we're going to end up in the same place here, just because the legal apparatus moves too slow. Maybe I think there's like some small chance that it gets super politicized and we just pick a stance on some important questions and it's like suboptimal. I think you're starting to see that in other parts of the world where people are wholesale like banning the models for like privacy reasons. I think I just saw this morning that Germany was doing that. And time will tell whether or not that's a mistake. My guess at this point is that's a mistake. And I think it's going to be interesting to see how those economies fare versus the other economies, if this actually is like really disruptive in the sense that in the sense that the internet is.
Alex, how disruptive do we actually believe this is? If you had to rank this new AI transformative technology compared to, let's say, the internet, mobile, public cloud, electricity, where would you rank it? Maybe, Ian, we can start with you. Is it above the internet but below fire? Like, how would you put it?
I certainly would put fire first. I think that's like of the most foundational technologies. I think the impact in truth on knowledge workers of generative AI, assuming that we have systems of truth that can fact check what the AI is creating and can create systems that you can trust, and thus you can remove human from the loop. I think the implications of generative AI are quite large on knowledge workers specifically. Most of what we do is take data in one shape and form, interpret it, and spit it on the other side in a relatively repetitive manner. I love to believe that I'm constantly doing net new thinking. It's just not the case. And I think over time, what will happen, and time is a great question here, is over what period of time, let's say over the next 100 years, I think we'll see a change in what knowledge work looks like. And there is a fundamental question of, do we end up with more or less knowledge workers? And what does the world of work look like as more of the base stuff becomes automated? From that perspective, I don't know if I would rate an LLM as foundational technology, like a generative AI model, is better than electricity. Certainly not. And I wouldn't rate it as better than like the piston or the steam engine. I think it is in a line with those things, but I wouldn't put it above them. And so the computer is definitely more foundational and will have a much longer term offspring than just the ability to train a deep neural network with an attention mechanism inside of it.
Good. How about you, Alex?
So I listened to a podcast where Doug Leone was talking about this, and he said that it's like the next internet. It's like a platform, exactly like the internet circa 1996 or something like that. I'm not sure that it is a platform. When I think of a platform, I think of something like mobile, which is like displacing desktop or something like that. I don't think that means that it's not important, right? You can have technology that's not a platform that is also important. But my sense is like, when you think about the companies that are going to capture all the value here, right? And I think this tells you about your question, which is like, how is this market going to evolve? My guess is that it is going to be, you think about Google search in like 1997 or something like that. Google became Google not because it had a better algorithm. It was an open algorithm based. They wrote a paper about it, totally public. Anybody could have picked it up. The thing that Google did, which distinguished it in the long term, I think, is that they took infrastructure seriously in a way that like Yahoo and Microsoft did not. Now, fast forward 20 years, they're able to serve search traffic at 100 times less the cost. They're able to like index and track and keep a copy of the entire internet and serve queries on it at 100th the cost of anybody else. And it's just very hard to keep up with stuff like that. My guess is that the same thing is probably going to be true of the LLMs. I think we largely know what the models are. Like we know how they're architected. People can train them. People are able to take the stuff that's happening in OpenAI, pick it up, or Google Brain or whatever, pick it up and build like cheaper versions of it that are in some cases competitive in specific domains. The way that this space is going, the people who are the best at training and the best at iterating and the best at keeping the costs of those models low, I think are probably going to end up winning in the long term. My guess is there's probably going to be a lot of very small applications that are augmented by something like LLMs. I think that it's probably not true. Like, I don't think of Google as a platform in the same way that I think of like mobile as a platform. And so I think that it's probably going to end up something like that, where you have this core product, which is offered to everybody, and then everybody uses it. And if you go look at OpenAI's website in the GPT docs, like their examples are like a sort of pre-unbundled last mile customer success suite, right? Where you can just plug in all of this stuff. And I think like that stuff is pretty compelling. So I don't know. My answer is not like a platform in the traditional sense. I think Doug Leone is wrong. I think that it could be still an enormous business. I could easily imagine OpenAI being worth $100 billion or something someday, depending on how well they execute. I know they're already worth 40 billion, but I mean like $100 billion like public company. I don't know. I'd love to hear if you think differently. Vitaly, you ran like a 300-person AI unit, right?
Yeah, so I'm actually quite surprised by the statement, Alex, and I don't think it will age well. And I think we're just seeing the first signs with I think what OpenAI did with the plugin system, right? It's fair rudimentary, it's just an API call, but I think if you squint a little bit and kind of imagine, that can be like a modern browser, right? That can, I think, totally change the way we interact with information. Like even if you think about what a website is, basically a prediction of the creator of the website and what would be the most frequently asked questions, and they put it in front of you in order to save you time. However, if really this LLM technology is now cheap enough, we might even ask ourselves, why do I need a website? Like, why isn't it just a Google search bar that you get and you ask whatever question you want and things like that? So I think we will start seeing the same way that the first years of the mobile, you start seeing all these M.dot websites, which were just that's a website in a small format. And it took time for Uber and Airbnb and these more native mobile technologies to appear. I think we just haven't seen it, but I'm fairly positive that it will come. Unlike, let's say, in crypto and Web3, we've been talking quite some time about it, and I still haven't seen like this killer app that really makes it. And Apple Watch is also, besides maybe healthcare, that is still, I didn't see something that is just fundamentally different. I think in AI, we will see it very soon. But Ian, I know you've been also playing with kind of these plugin systems. What are your thoughts?
I mean, I think the plugin system, the moment I saw how you register a plugin, I was actually kind of flabbergasted. I just spent the last 30 minutes of this podcast saying how I think they're not going to take over the world. But at the same time, the fact that the system is learning based on the open API schema to figure out what it can do with it and is creating actions from that is still pretty incredible. And there is a little bit of what happens if you hooked up a plugin that could launch a rocket, right? Or crash a car or detonate a bomb. And then the model decided to do that because it hallucinated that something was occurring that wasn't occurring. So you can create like a theory or a version of the world where you believe, okay, that could be dangerous. Yeah, I could see how that happened if that was allowed, if that was set up that way. I think the plugin ecosystem is really interesting because what it really does is it starts to, if we believe that the LLM is capable of reasoning, and it's not just regurgitating relational data that it's probabilistically trained upon, and it's actually formulating the ability to reason and is actually truly understanding the general concept, is actually capable of doing if this, then that, truly in a logic-driven manner, deterministically, then what these plugin systems enable for them to do is to fact check themselves and form actions. And that's pretty incredible. Or if it can come up with a potential hypothesis, leverage a plugin to check against what we know about the real world, because a model doesn't have that information. It can hypothesize potentially that information because it's seen some text associated with that information, then go test that against some observed real world state, whether it's, the weather is actually 8 degrees. So the suggestion for a winter shirt is not good. I should instead, it's a nice spring day in Canada because it's 8 degrees Celsius. That ability to reason and use real world information is what the plugins actually surmount and enable. So I think they're very interesting. I think it's like to your point, if you narrow your focus, you just think, okay, what does this actually enable? If you accept that if true on everything I said is my preamble there, then pretty incredible. Now, I still am skeptical on my preamble that we don't actually know. Do these things truly understand, or are they just the best and greatest memorization machines in the world? But at the end of the day, if they do, and they're truly capable of deterministic thought and are truly capable of Boolean level decision making, then it unlocks a huge amount of potential, because now I can hypothesize, I can check, and I can make a decision all in one model or one ecosystem of models and ensemble models.
I think the models themselves it's pretty clear what their limitations are. One way to think of models, in my view, is to think of them as like very probabilistic databases, where you're essentially learning a representation of all of the stuff that exists in the world. And you can query that stuff, and you can take that knowledge base and you can transmute it into a variety of different formats that are meaningful to humans, right? So images, text, code, markdown tables, like all of this stuff that humans find sensible. But I don't think that there is actually going to be a way in the long term to really make sure these models are completely coherent. And you wouldn't want them to be, because the magic of the models is that when you give it a prompt, it goes and starts to enumerate the tokens in that space, and you want it to explore a bit and to pull associations that wouldn't otherwise normally be a part of a relational query or something like a database. That's what you actually want in the model. In order for that to be true, it has to be inconsistent. There are very few things that should be 100% consistent across all of the space of prompts that you could issue. And when you think about it, that's like how people do it too. If you remember writing, like in the AP exam, right, you get an essay prompt and you like write some notes and you try to prompt yourself, try to figure out exactly how you're going, like all of the facts that you want to put into the essay, and then you try and enumerate the essay. And my guess is like the plugin system and like lane chain are probably going to play like a similar role where you have this like knowledge base and you prompt in a bunch of different ways to get a more coherent response out of it. And you can use that more coherent response as input or output for a variety of different things. I think that is extremely exciting, but the limitation of the model prevents what the model itself can do. Like everything around the model is going to have to account for that fundamental fact that you have this cross entropy. You want some mixing of facts that are not necessarily true, because you want to encourage the relations to bring serendipity to the response. That's the function of the model, in my view.
Yeah, so let me actually try to propose a different way of thinking about it. And I think we kind of use the word simplicity and maybe describe it as something negative, but there are so many cases where actually simplification of something unlocks so much value. And I'm talking to everything from taking electricity and standardizing on it. And just now everyone has just a plug that gave birth to all of these devices that we have in our house, everything from commodity trading or mortgage-backed securities and all of that, or the way that display advertising on the internet works, just because we created a format of these enumerated blocks with images. And once we created that unified interface, it gave birth to just so much value on top of it. And can we imagine something like that also happens with whether it's the plugin system or something similar, where once we start creating these interfaces that are now optimized for large language model in a similar way that many of the REST interfaces were optimized for machines, now we can take it one level up and then create the sort of power that we haven't seen before. Kind of, Ian, what are your thoughts there?
I think it's a super interesting question, right? Like I think about the standardization of electricity, you think about like the cargo container and how it changed supply chains. I think for LLMs, what if with the plugin ecosystem, right? What about the ability, the inputs, the outputs, and the embeddings? What does that enable us to do? Do we end up with this like giant base of standardized embeddings where we now have a concept and coding for every type of concept you can think of? That'd actually be pretty incredible, to be honest, if you could translate from this is the embedding for a cat, and every machine in the world understands that embedding to be embedding for a cat across the board. Right now, we have the ability to cargo containerize a generalized concept, right? Not so much code, but like the actual concept, and I could send it to Alex, or I could send it down to Llama at Facebook or whatever. I think that's really interesting, because before we never had the ability to translate like actionable knowledge. We've had text, right? I could write out, here's Fermat's theorems. Someone had to interpret it, and then someone had to then go do something with it. But now the ability that you could take this idea of containerized thought, these embeddings, and if they are standardized across the world on the same models, now I can patch different pieces of thought together, different concepts, and those could be actionable. That sounds pretty incredible. Now, that's pretty far out. I definitely don't think we're there with the early embedding stuff, but that's where I see a lot of this going. In the same way that we would push some code around a Docker container, could you push a generalized concept of how to move a lever, right? Or how to calculate the digits of pi in a way that we can't today? Is there a new modularity? And I'm actually really curious to get Alex's take on this, because I'm sure he spent some time thinking about this, because I know he spent a lot of time thinking about language.
I think it's going to be really hard. The thing that the models do is they just predict the next token, right? And it's really astonishingly good at that. But my takeaway, I think, is the same as many researchers who have been in the space, which is that I think the implication of this is that language is actually simpler than we had originally thought. Like, we used to think it was impossible to understand like the complicated structure of the language, but the fact that we have this like billion parameter model, which can do a pretty good job of text synthesis, has taken us from text synth will be an open problem until we die. We are all going to be dead, and it will still be an open problem, to 100% closed book solved problem in like 10 years, but arguably really like 4 years, right? As they exist now, I think it's very hard for me to believe that like the models themselves are going to be amenable to generating extremely precise instructions. I think you will end up building stuff around it whose job is to do stuff like that. So I could imagine using LangChain or something, prompt a model in various different ways, or interactively prompt it, get code, feedback and error messages, get code, feedback and error messages, and iteratively build up something. Like, that's the sort of thing that I could imagine, but I don't think that's in the purview of the model itself. And I don't think we'd want it to be. I think if you treat the model as like a bad database that generates coherent and consistent like tree-based stuff, my belief is that we'll get a lot more leverage that way than trying to make it super consistent, trying to make it have super global beliefs. I think if you look at the people who do this sort of thing for a living, like Wolfram, like they embraced it. They just were like, hell yeah, bring like plug us right in. And I think that like they've been working on this problem for 40 years or so. And I think that in their posts, it reflects the state of where people like me are at, which is that they believe that the prompting is a way to get more precise, more algorithmic knowledge out of Wolfram Alpha. But it's not going to replace it. And I think that's probably true.
Let me try to actually use a different analogy. So you said that, hey, a large language model is like a bad database. Let me try to actually offer a different way of looking at it. With the plethora of services we have in the world, if we look at the way we interact with them today, which is REST, is we really live in a world where we have like millions of these tiny assembly languages where you have a very precise instruction set. Okay, go and put or post or get or whatever. And that every single time it does like this one specific thing. And we have to add instruction by instruction to all of the services we have available in the world, right? Which probably millions of them. Now, we can look at actually large language model and their ability to interpret these services and actually combine and kind of reason about them in a different way as almost like a virtual machine that is now an abstraction layer on top of all of these millions of x86 clones that we have with a completely different instruction set once. So if one, maybe, do you agree that this is a reasonable way to think about it? And number two, if so, then can that also unlock just this huge value that we couldn't do today?
Sure. Having 32 kilobytes of memory is a lot like having 32 1,000 tokens of like memory, right? Like I think that it's like an alien programming model. It's extremely weird, right? You have a model of like prompt space, like how to get knowledge out of your, I know you don't like the word database, but yet you have this like knowledge store, right? You have this extremely weird query language, right? Or this extremely weird assembly language, and you have to figure out what weird token combinations to pass it in order to get the stuff that you care about out. I don't know. It's like kind of mind bending.
Yeah, I was mentioning something slightly different. It's not so much about the memory of the virtual machine. It's just the fact that before you had to develop code for every single, or at least compile it for every single machine. And now you can write it once, but also the number of machines was not as high. But now if you think about the number of services and number of APIs, the number of that, we're probably talking 6 orders of magnitude larger. And then we can like literally just get a single abstraction layer, just a virtual machine. You could talk to it, and then it figures out how to get what you. So Ian, what are your thoughts there?
I think it's something I've been thinking about a lot, actually, is the ability for generalized reasoning about some code. If I can analyze an example, go back to the plugin, I can analyze an open API file, a schema from my APIs, and it can extract what the underlying intention of that API endpoint is and extract how to call it, and then use that in a chain of prompts. That actually like drastically lowers the barrier to integrating systems together, assuming it can do these things. And if we think of modern day programming, we think it is in the cloud is akin to basically gluing a whole bunch of APIs together with popsicle sticks and some gum and some glue, and then putting in AWS. All of that is handwritten over and over and over again. And I think one of the reasons I was like, big idea here is now I have a thing that can read, like independent of how the plugins are being used today, but now like I have a thing that is capable of reading some standardized file, generally extracting a summarization of what those things doing, and then I can hook something into that to call on it when prompted, when needed. That's pretty incredible. Now, I think there is the general challenge here is always, well, there's probability. It's not deterministic. There's a percentage of correctness there. There's an inaccuracy as well. There's an error rate as well. There's hallucination as well. But long term, like that scale here is pretty incredible. And so what the final question I keep coming back to in my day-to-day job is, what percentage of error does error have to be for this thing to not be useful? Or an inverse of that is, how good does it really have to be for it to be useful? And I think the reality is, with if humans in the loop, if it's at least 80% correct 80% of the time, then that makes building applications a lot faster. It makes the translation between different applications a lot faster. It makes finally changes what your day-to-day is. The plugins opened up new ecosystems to add to that 32,000 token context, right? So there's just so much available space. It's so much capability that's unlocked through the plugin ecosystem based on the basic idea that there's a model out there that can look at an open API schema that can generally extract what that API enables you to do, and then allows you to write a prompt layer on top of it. That's incredible.
So Vitaly, I think the reason why I can't quite get behind this, it sounds like you're describing like LLMs as more of an action-oriented thing, like a virtual machine that gives you access to all of these services and stuff like that. The reason I can't get behind that is because at its core, I do think that LLMs do one thing, which is they represent and store a bunch of knowledge, right? They don't really do anything in themselves. You have to connect them to things to do things. And the thing that is remarkable about the knowledge store is it's pretty incredible that you can get pretty coherent human seeming responses, or like pretty coherent code or pretty coherent images out of this like representation. But whatever it gives you, you still have to translate that into action at some point. And as long as the knowledge stores are constructed in the way that they are constructed now, general purpose, like knowledge stores where like the facts could be wrong, the instructions that it retrieves for you could be slightly incorrect, I think there will have to be like a layer, like a mediating layer that actually translates that into action. I think that's what LangChain is. And that's why I'm mostly so excited about that project. So I don't know, it reminds me a little bit of the kernel operating system versus like kernel services versus shell versus user space arguments. It's like the kernel itself doesn't actually do that much, it just schedules processes, right? You need all of libc, all of this other stuff around it to actually make it useful to normal humans. I think that is what is going to end up happening with the LLMs. So you have this kernel, which is this, I think the right way to think of it is like a knowledge base, because that's what it is. It's a representation of all the knowledge that we have. And there's going to be a bunch of stuff around it, which makes that knowledge useful to people in various different contexts. And I think that's super exciting, but there's still so much of that owl to draw left, right? It's not going to happen tomorrow. And I think that's why everybody is excited about the plugin system.
Also, to touch on Ian's point about the correctness and kind of all of that, Ian, it a little bit reminds me of kind of the debates people had about memory optimization by compilers, right? Everyone said, hey, these compilers are not going to do a great job. I understand my program. I understand really what we do. And I think today, I don't know, probably for 99.9% of the people in the world, the compiler probably can do a better job at optimizing memory than they can do themselves. And to your also point about error, in some cases, I would argue that these errors might be actually a positive, because you have no ability to actually think about all the APIs that exist in the world, right? But let's say if now an LLM could easily, because it's such a, again, orders of magnitude less information that it already has, go and survey all the APIs in the world and kind of have some determination which one of them is the best by quote unquote predicting this token. And then let's say you're a developer that is not familiar with Twilio, and you still say, hey, find me a way to send a text message, right? Based on this or that. And it can do it. And in some cases, you will say, oh, like maybe it's the wrong thing. What is this Twilio thing? And then it'll say, oh my God, like this is exactly what I need. So there will be this discovery that it's impossible for us to do as human code writers, but it probably will be available with these LLMs.
I 100% agree with you on this, by the way, because like the way I think of these generative AIs they're generative. They're amazing at being creative. They're amazing at creating possibilities of things that could work. They are not good. They don't have the capacity. It's, to Alex's point, it's about the system around them that tells them whether the thing that they dreamt up is correct. But certainly, also to Alex's point, they are an amazing database, probabilistic database of things that they've learned. And I think that's the most amazing part about it, is you have this giant probabilistic tree of data that you can query, and the way you query it will return different results. And that is actually a feature, not a bug, for some use cases. And I think the challenge, going back to the letter, is society has to identify where that's a feature and where it's a bug. And I think liability law will help us identify where those things are a bug. And I think where they're a feature, we'll see like drastic transformation.
So I'll go one step further than you, Vitaly. I'll say that the only reason they're interesting is because they capture associations probabilistically. I think that this is also a way that people work, right? Like people hold contradicting beliefs all the time. They reconcile them. There's like a supervisory process over our own whatever, however we're storing information. I think that it's really important way, like tool for how people think. Like they have access to all this stuff that they know. And they know, most people know that they hold beliefs that are not consistent at all. And being able to prompt yourself in different ways generates like connections that you didn't know that you knew until you start to put things together. And that's one of the reasons why writing is so powerful, is because it forces you to prompt yourself and enumerate all of what you're saying, right? Like that's why people say writing is thinking. And so I think it's so interesting that half the field is so interested in making the knowledge base more consistent. Just seems to me like that's the exact wrong approach. I don't actually care. I think of that as like a primitive, a way of capturing everything that we know and making it accessible to people in a way that is like nothing we've ever seen before. I don't know if there's anything like this in the history of computer science, which is like actually kind of saying a lot, right? I think we're right on the cusp of something really interesting where you have this ecosystem of stuff built around it. I think this is the only reason why it's interesting, is because it captures stuff that's associated probabilistically, and then your job is to make sure it's coherent.
Well, folks, now we have finally seen Alex saying something very positive about AI, and I think this may be a good kind of point to wrap up our episode. Ian, Alex, thank you.
Curmudgeon? Is that a thing?
Yes.
Thank you so much for joining me today, and folks, I hope you enjoyed the conversation.